Hey gang, hope you've had a good day today. So in today's video, we're going to be going over question 5 from Bluebook Test 1, Math Module 1. And this is going to be focused on reading graphs and interpreting their information. And we'll start with the actual question, and then we'll do 3 follow-ups that should build on this question's concept. And you can leave in the comments any questions you have, or if you want to see more questions like this or any confusion. Let's get started. So the graph represents the total charge in dollars by an electrician for X hours of work. The electrician charges a one-time fee plus an hourly rate. What is the best interpretation of the slope of the graph? Okay, electrician, pretty steep graph. Seems like he's probably making pretty good money. I hear you make a good living on being an electrician. I've never actually met one. Met plumbers, handymen, electricians. Haven't met them, but they must be doing well for themselves. So what is the best interpretation of the slope? Right, okay, and let's look at our options. A, the electrician's hourly rate. B, the electrician's one-time fee. C, the maximum amount that the electrician charges. And D, the total amount that the electrician charges. Okay, so we're looking at the chart, right? And you think about it's a linear graph, right? Automatically, you can think of y equals mx plus b. And, right, m is the slope, b is the y-intercept, and m is a rate, right? It's a rate of change. So if we're talking about the slope, it's a rate of change. So it should be his hourly rate, right? The one-time fee would be the y-intercept, right? Like where you're starting at with him, right? His fee for just showing up or anything. And then the maximum amount and the total amount, that's not really represented here. That would be represented if we had like a peak, but we're not told there's a peak or an ending. As far as we know, if he works a million hours, he'll keep going and make 10 million bucks or something, right? And as he should, your labor is priceless. Well, it has a price, but it keeps going up the more you work, right? So, or at least it should. The graph, we'll try this follow-up question and we'll see how you do with it. Try to answer it right on your own first, and then if you feel like I got it fully, you can just skip ahead, go to the next question. But if you have questions on it or you want to see how I do it, if it's more efficient, then keep watching. The graph represents the dwindling funds in a person's bank account after they quit their job and go on a spending spree. The x-axis is in days, the y-axis is in dollars. What is the person's daily rate of spending? Okay. I'm a little concerned that they're going on a spending spree with only $40. I mean, maybe this is like 1900, right? And they have a lot of money then. 40 bucks would be a lot 124 years ago. Right now, 40 bucks, a couple good meals maybe. But, this is how they live. I'm not going to judge them. I'm happy for them that they could quit their job and go on the spending spree. So you're at 40, right? And then this is the dollars and this is the days. So they get down to 10 in 10, or they get down to 0 in 10 days. So it's $40 are spent in 10 days. And you get $4 a day, which is D, right? And just looking at the answer choices, let's think about how they would think you would make the mistake. $40 would be if you just see the y-intercept and say, that's how much they spend, and you didn't think about daily rate, right? $10 would be if you confuse the axes and think 10 is the dollars, and you don't think about slope, and you're just thinking he spends $10. And then 25 cents, right, is going to be if you flipped it and you did the slope in reverse, right? But if you do it y over x, you're going to do 40 over 10 and you'll get $4. Okay. So you may notice right after these two questions that the math here isn't too complicated in terms of the actual calculations you have to do. It's more about just reading the graph and thinking it through. Okay, so let's look at this one. A boy shoots a basketball up into the air. The graph represents the time in seconds and the height in meters of the ball. When will the ball hit the ground? Okay, so the time, right, is going to be this way. in the x-axis, and the height is like this, right? Because you wouldn't have time to go up and then back down. Time is going to be going straight. But height would make sense to go up and then back down to the earth, because you're throwing something up and what goes up must come down. At least that's what they've been telling us. So we have to do, when will the ball hit the ground? Let's look at our answer choices to sort of get some guidance. 0 seconds doesn't make sense because that's when the ball would sort of take off from the ground. So we can cross that off. 0.816 seconds. Okay, that makes more sense, but that's here, right? And that is the peak. So that's when the ball is at its peak. That's the vertex, right? So that's not going to work either. And then we're left with these two answer choices, right? And how would we know what it is, right? So parabolas like this, right, are symmetrical across the across the vertex. So if you drew a line down, you'd have a line of symmetry, and you're as far away from here to here as you are from here to here. So we're trying to find how long it takes to get here, right? We know it's going to be between 1 and 2 seconds. And then that will happen as far away as the first one went, right? So this was 0.816. So this part's also going to be 0.816. So we're going to double them. I'm not even going to do the math, right? You could add it here. But if you look at the answer choices, 0.8 plus 0.8 is 1.6. So the one that makes sense is D, 1.632. All right, and you could do the math, but you wouldn't want to do the math. You want to use the answer choices to help you be fast. Save your energy for the harder ones. Okay, so we'll do one last one, I think, and then we will be all set. So this chart shows the distance in meters on the y-axis and time in seconds for someone on a bicycle. How far do they travel in 1 minute? Okay. So you have time in seconds on the x-axis, right? So you could find the rate per second, right? And then multiply it by 60. And so the rate would be 150 over 200, which is 3 over 4. And then you just multiply that by 60. And you'll get 45. And that's not too bad. But another thing you can do is look at the chart and see how far he's gone in 60 seconds. So 60 seconds would be here. You draw a line up, right? Or you try to calculate with your finger. And it's between 40 and 50, and it's 45. Okay, so that is how we would do this one. Again, like the previous ones, there's not too many calculating things. It's about reading the question carefully, looking at the graph, understanding what the graph is communicating, and then using that to eliminate choices and finding the right one. All right, so I think that'll be it for today. If you have more questions on this or want to see more material like this, let me know. If you want to see different material, that's coming, that's already existed, and it'll come more. And if you have specific types of questions you want to go over that are on the SAT, ACT, GRE, anything really, let me know and I can make a video about it. And I hope you all have a good night. Like always, like and subscribe if you've enjoyed this video, and I'll talk to you all soon.